Hello class, this is a video tutorial on the normal distribution and standard deviation part 2. In the previous video we went through how the standard deviation and the normal distribution have a relationship, in that depending on how many standard deviations above and below the mean is given, they represent different percentages of the data. Let's go through it very quickly. So if we have all of the data and it's normally distributed, the mean cuts everything perfectly in half. So there's 50% above and 50% below the mean. Within one standard deviation above and below the mean is 68% of all the data. So 34% are from the mean to the first standard deviation, and 34% are from the mean down to the -1 standard deviation. And I hope we don't have to go through too much detail for all of these, and you get an idea behind the meaning between each of these. So let's apply this to an example. Here we go. An assessment task has a normal distribution with a mean of 67 and a standard deviation of 7. So let's write this down first into our given, or you can draw it yourself. Into our normal distribution. So here's our normal distribution. Just get rid of this little marking there. Now the mean has a standard deviation of 0 because we haven't moved from above or below the mean. So the mean value was 67. So let's write that in. So 67 is our mean value. And the standard deviation is 7. So let's write that in. So sigma x, or it could be s of x, one or the other, is going to be 7. So what we need to do first is figure out what these values are for being above and below the mean. So let's do this very quickly. So to be above by 1 standard deviation means we're going to take the mean, 67, and we're going to add the standard deviation once. So that's going to give us 74. So being 1 standard deviation above has a score of 74. If it's 1 standard deviation below, it's going to be 67 take away 7. Well, that's going to be 60. So 1 standard deviation below, the mean is going to be 60. And this continues. You can go ahead, fast forward this part if you understand. You can copy along and fill it out yourself. But let's do it now. Let's do 67 plus 2 times the standard deviation. That's going to be 67 plus 14, which is going to be 81. It's 81. And if we want to do 67 minus 2 lots of the standard deviation, 67, sorry, that was 81. 67 take away 14 is going to be, take away 2 times 7, that's 53. Let's do plus 3 and minus 3 standard deviations now. So 67 plus 3 times the standard deviation. 3 times. It's going to be, that should be plus. Please calculator work. Plus 3 times standard deviation. That's 88. It's going to be 88. And if we do a minus, so 67 minus 3 times standard deviation, that's 46. Now we're going to be utilizing these values to answer these following questions. So there are a total of 850 students. What we need to do is figure out how many of them scored between, well, the first one is going to be between 46 and 88. So let's write that in first. 46 is down here, all the way up to 88. So we want to figure out how many students are between there. Well, we know that 99.7% of all data is between -3 standard deviations and +3 standard deviations, which is exactly what we have here. So between 46 and 88 is 99.7%. Let's write that as a decimal. So 0.997 times the total number of students. Use a calculator for this. 0.997 times 850. That's going to be 847, because we're going to round down from the 0.45. Let's continue on. From 53 to 81. So between 53 and 81. So let's write this in. 53 to 81. So between there, well, as you can see, that's -2 and +2 standard deviations, which corresponds to 95%. So this is going to be 0.95 times the total, which is 850 students. So 0.95, which is 807.5, which I'm going to round up to 808. So approximately 808 students. Let's do this again. And I'm hoping you're beginning to see the pattern here. So between 60 and 74. Let's mark that in. So from 60, which is -1 standard deviation, to 74. That's +1 standard deviation. Well, that corresponds to 68%. So this is going to be 0.68%, or 68%, sorry, of 850. So let's get rid of this. 0.68 times 850 is 578 students. Okay, so those are the more straightforward examples. Let's move on to the slightly more difficult ones. So from 60 to 67. So from 60, which is -1 standard deviation, to 67. So what we really want is just this area here. So just that area, let's look at this graph here. So -1 standard deviation. So we only want this area here. That corresponds to 34%. So that's going to be 0.34 times 850. 0.34. That's 289 students. From 67 to 74. Let's mark that in. So from 67 to 74, sorry. 74. There. So that corresponds to this one. That's also 34%, which we already have the answer for. So 0.34 times 850. The answer is already shown. That's 289. From 67 to 81. So from 67 to 81. So that's just from 67 to 81. Let's mark that in. So between 0 standard deviations and +2, that corresponds to this area here, this one in orange. That is 47.5%. So let's write that in. It's going to be 0.47.5% of the total, which, if we calculate 0.475, is 403.75, which will round up to 404. So I hope that gave you a further insight into utilizing the normal distribution to calculate the numbers of people within a data range. Hope to see you in the next video. Best of luck.